Okay, everyone, I'm going to talk about Newton method. Okay, so what is Newton method? It is a method that Newton used to solve the root for the polynomial. Okay, we know the formula of some polynomial, for example, quadratic equation. This is the formula to solve the root. Okay, so when x is this, the y will be 0. The cubic would be much more complicated, which is not in our syllabus. And let's say you're given a polynomial like this, and you're asked to find out the root. There's no formula. Okay, so Newton came up with a very good way to solve the x, but his method will not give you the exact value. His method will only give you an approximation. And how accurate that approximation is depends on how many steps you want to do. Okay. Before I go into detail, I'll give you a pictorial idea of Newton method. For example, we have this simple equation. We're using something very simple, so actually we don't even need Newton method to solve these questions, but we can use Newton method to solve any polynomial questions. Okay, but having said that, using Newton method, you will never find the exact value. You will only find the approximation value. And how accurate that approximation value depends on how many steps you want to do, how hardworking you are. Okay, so we are using x squared minus 2 equals 0 as an example. As you can see, the answer is plus minus square root 2, right? But with Newton method, we can get the approximation of this also. So this red line, this red curve is x squared minus 2 equal to 0. So to do Newton method, I must start with a random number. Okay, I start with 4 in this case. Okay, not me, the textbook. The textbook start the whole thing, start the whole process with 4. Must you choose 4? No. You can choose 5, 6, even in this case 100. Okay, you can choose any number you like on this side. It's just that the further you choose, the more steps you may need to get close to your root, which is here. Can you see for yourself? You choose 4, so here. If you choose 10, it'll be here. So then it will be harder for you to get close, which means you have to do more steps to get close to your answer. But with computer, actually, it doesn't really matter. So Newton method, during his time, was not exactly a very easy method because there was no computer and everything has to be done manually. So it can be pretty tedious. But with computer, Newton method has become very, very simple, very, very efficient. Now, let's say I start with 4. So with this 4, I can have a point over here. Am I right? So this point is x is 4, y will be f4. So with this point, I will draw a tangent. By drawing a tangent, it will cut the x-axis. By cutting the x-axis, then this will be my new x. Just now my x was 4, now it will be 9 over 4. Then this 9 over 4 will give me a new point on the curve. Then I'll use this point to draw a new tangent and cut the x-axis again. Then this will be my new x. So I've done how many steps? First step, second step. Then I'll be using this point to draw another tangent. Okay, I will draw another tangent. Then this tangent will cut the x-axis again. And as you can see, the more tangent I draw, eventually it will cut almost at the root. Okay, it will never, theoretically it will never reach, but it will be very, very close. So this is the pictorial idea of Newton methods. By using approximation method, you get the root eventually. You get the x that you actually want. So 4 is not so good. Then with one step, this value is better. This is even better. Then as you get closer and closer, eventually you get an answer that you're probably happy with. So the technical part, the technical part. This point, x is 4, y is f4, right? Then what is the gradient of this blue line, this tangent? The gradient is f prime. I hope you still remember chapter 17. F prime is the derivative, so it is the function of the gradient. Then you sub x equals to 4 into that gradient function, you get the actual gradient. Therefore, this is the formula of this tangent. Okay? Y minus this divided by x minus this equals to the gradient, which is f prime 4. So this is actually the equation of this blue tangent. Now, this blue tangent will cut x-axis at this point. So how do I get this 9 over 4? It's actually by sub y equal to 0, because this is when y equals 0, into this equation. So I get this. So, and then I get this relationship. Okay, this is a key. Okay, this relationship is a key. X, eventually you get 9 over 4. So from this, you get a better answer. My original answer was 4. I assume it's 4, it's not. So I got a better answer, which is 9 over 4. So if you're not happy with 9 over 4, you repeat the process. You repeat this process. So you can see that this is actually the relationship. 4 is the first number that you choose. So if you choose 5, then this will be f5. This will be f prime 5. So if you choose 10, then this will be f10 over f prime 10. Okay? So, okay, now then we have to go to the okay, let me show you this one again. So the pictorial idea. So basically, Newton method is using this relationship. This is a key formula for Newton method. Xn is the original number that you choose. Xn plus 1 is the answer by doing one step. So how accurate you want this to be depends on how many steps you do. Steps is n. So this is the first one. Then you get a new x. So one step, you get a better answer. Then second step, you get an even better answer. Third step, you get an even better answer. So you keep doing this, eventually you will go to this point. Okay, theoretically you will never be there, but you'll be close enough. Okay, now let's go to the Excel part. So I have now explained the theory of the where's Excel? Okay. I have now explained the theory of the Newton method. Now let's come to the practical method. How do you solve Newton method with your CAS calculator or Excel? Because it has to be done with machines. You can't do it manually. It would be too tedious. So just now we introduced that the key formula is this. This is a Newton method formula. Xn plus 1 equals to xn minus fxn over f prime xn. Xn is the first x that you choose. So I in this case, I give you two examples. One is 4, which is given by the textbook. The other one, I choose 10. So you have to come up with a table. A table with n, xn, and then fxn, f prime xn. Then what do you think is this? This is xn. This will be xn plus 1. Then this will be xn plus 2, xn plus 3, so on and so forth. Okay, so n is start with 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay, in this example, I start with 4. So at first 0. X is 4, so you key in 4. This one you key in 4. And fxn, do you key, so how do you get this value 14? Basically, it's by you sub x equal to 4 into this equation, your original equations. 4 squared minus 2, 16 minus 2, 14. F prime x is 2x, right? From this, the derivative is 2x. So 2 times 4 is 8. But you are not allowed to key in 14. If you key in 14, then you can't use the computer anymore. You have to key in the formula to help you calculate. So instead of keying 14, you don't key in the number yourself. You let the computer to calculate for you. So what is the function to get 14? It's actually this number. So you don't key the number, you key in the position. What is the position of this 4? The position of this 4 is D15. So D15 squared minus 2. Then you get 14. Once you press enter, you get 14. This number is 2x, so 2 times D15. Okay, now comes the most crucial part, this number. How do you get this number? This number is actually xn plus 1. So it equals to xn, which is this number, minus this number divided by this number. Therefore, you have to key in. That's why I highlighted it. I highlighted this number. So you have to key in this formula into this box over here. D15, which is this number, minus E15. E15 is this number. Divide by F15. This number. Then you press enter, you get 2.25. So 2.25 is one step closer to your actual answer. But it's not good enough. If you want to have a better answer, now what you need to do is just drag. So this 2.25, will help you calculate the next one. Calculate the next one. Then with this 2 number, you can get a better answer for xn plus 2. Now you're better, you're now even closer. By doing 2 steps, you're closer to the final answer. Okay, so I just drag all the way. Drag all the way. Drag all the way. Okay, so how do you decide what is the answer? The moment you see 0, that will be the answer. Then, the moment you see 0 here, this is your solution. Okay, the moment you see 0, this will be your solution. So that is Newton's method. Why is it 0 here? Because the computer can't make it any smaller. Okay, this is restricted by the computer. The computer is not powerful to make it any smaller. So when you do until step number 6, it will reach 0. Okay. Actually, it will never be 0. It will just be very, 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 very small. But to the computer, it can't differentiate anymore. Just like our cats, I think to a certain limit, it can't differentiate. It's too small. But that is good enough. Okay, if computer can't even tell what about human being, so, but it depends. Let's say if your computer is even more powerful, then perhaps you can go even lower. But this value is good enough in a way. So if you start with 10, xn with 10, then you need one more step. In this case, actually, the computer is not much. Actually, just one more step, you get your answer. This one, you need 6 steps. This one you need 7 steps. But as this number goes bigger, you need a little bit more steps. But it doesn't make much difference with computer. Okay, so that is Newton method